6A, we're talking mortgage payments. The average mortgage payment in the US, $982. It's normally distributed. Standard deviation, 180. Find the probability it's more than 1,000. If I were to guess, I'd say that it's almost 50%, a little less than 50%, right? Because the average is 982. That's just a little above that. So I'm guessing a little under 50%. We'll see. Part A, the probability that the payment is more than $1,000. So that's the probability that our data value is more than $1,000. So we know that our data value that we're looking at is 1,000. The first thing to do is change that into a z-score. You use this formula to change to a z-score. I'll write it up here. That says the z-score is the data value minus the mean divided by the standard deviation. So our z-score will be 1,000. That's our x. That's our data value. Minus mu, our mean, 982, over 180. Plug that into my calculator and I get 0.1. So for this data value, this is our z-score. So we go to our table and find the probability that we're to the left of that z-score. So you put in 0.10 on the outside and look in the middle for the area, and the area is 0.5398. So 0.1, our z-score is right there. We're looking for more than our z-score. We know that this area is going to be 0.5398. So then to find this shaded area, we'll do 1 minus that. Part B, probability that our payment is more than $1,475. Think about this for a minute. If this is the average, the probability that's more than that, I bet this is going to be a pretty low probability. That's quite a bit higher than the average. We'll see. We're trying to find the probability that our data value is greater than 1475. So our data value that we're going to look at is 1475. We need to change that into a z-score. So we plug it into this formula again, our data value minus the mean divided by the standard deviation. Put that in my calculator and I get 2.74. I look that up in my table and find the probability that I'm to the left of that. So 2.74, that z-score is going to be right about here. So I'm looking to the probability that I'm to the right of that. I want to know the probability I'm greater than that. This number gave me this area. So now to find that little area, I just do 1 minus. Just as we suspected, it's a rather small probability, less than 1%. The probability that our payment is between 800, or our x value is between these two values. That's what I'm looking for. So I have two x values that I need to turn into z-scores. I've got x is 800, and x is 1150. I'll turn those both into z-scores. Data value minus the mean divided by the standard deviation. So negative 1.01, about here. This is the z-score that lines up with the data value of 800. The z-score that lines up with the data value of 1150 0.93. That's right there. So I'm looking for the probability that I'm in this area. Guess. What would you guess? 70%? 60%? Well, let's figure out exactly. Let's go to our table and find out the probability that we're to the left of this z-score. So you find negative 1.01 on the outside of the table and look for the probability on the inside of the table. And the probability that we're to the left of the z-score of 0.93. So you find 0.93 on the outside and then look to the inside for the probability. So the probability we're to the left of this z-score is 0.1562, about 15%. The probability that we're to the left of this z-score is about 82%. So we just subtract them to find that inner probability or inner area. .6676. My guess of 70% was kind of close. PhD student average salary, so average mean is 12,837. Data is normally distributed, so that means it has the shape of the bell curve with the standard deviation of 1,500. I want to know what's the probability that the student makes more than, or the data value is more than 15,000. Let's guess. First of all, 15,000, that's quite a bit above the mean. I bet it's going to be a pretty low percentage. Let's see if I'm right. The data value I'm looking at is 15,000. I need to turn that into a z-score. I'll use my z-score formula, which is z equals the data value minus the mean over the standard deviation. We should be getting pretty good at using that by now. I should get a positive z-score when I do this. How do I know? Well, I know that 15,000 is above the mean, therefore that's going to give me a positive z-score. My z-score is 1.44. That's about here. So I want to know the probability that someone makes more than that. So I look up the probability for my chart, but that's going to be the probability that I'm to the left of that z-score. So I look up the z-score on the outside, get the probability out of the inside. So I know that this area, the area to the left of that z-score, is 0.9251. So that means I want to know this area, so I'll do 1 minus that. About 7%, 7.5% chance that the student will make over $15,000. Probability the student makes between 13,000 and 14,000. Let's guess. 13,000, that's a little more than our mean. And then 14,000, that's quite a bit more than our mean. So we're going to be kind of in this area, I'm guessing. I'm going to guess a quarter, 25%. Let's see if I'm right. So we want to know this probability. What's the probability that our x, that our data value of the person that we choose is between 13,000 and 14,000? To do this, we have to get z-scores for both of these data values. We'll use the z-score formula. So the z-score for 13,000 is 0.11, right about there. And I'll get a z-score for 14,000 using the z-score formula. Data value minus the mean divided by the standard deviation. Put it in my calculator, 0.78. So that's right about there. So I want to know the probability I'm in that area. So I'll use my chart. I'll find the probability that I'm to the left of this z-score. I look up 0.11 on the outside and find the probability on the inside. It's 0.5438. I look up the z-score 0.78 on the outside. And on the inside, it'll tell me the probability I'm to the left of that z-score. And to find the probability I'm in the middle of those two, I subtract. About 23%. What did I guess? A quarter? Not bad. Average commute is 25 minutes. My mean is 25. Data is normally distributed with a standard deviation of 6.1. You notice all my problems say this. Data is normally distributed. That's more important than you think. Because if your data is not in the shape of a bell curve, you can't use this stuff. My bell curves always get weird. They're supposed to be symmetric. Maybe your data is like this. Maybe you have an equal number of people who take a short time to go to work versus a long time to go to work. So if your average is here, maybe you have more of this kind of a shape. In that case, you can't use this method. In order to use the bell curve, the standard normal curve, you need to have data that is normally distributed in the shape of a bell curve. So that's why it says that in all of our problems. Again, my bell curves are supposed to be symmetrical, the same on both sides. A, find the probability that a randomly selected driver has more than a 30-minute commute. So we want to know the probability that our x value is greater than 30. So the x value we're talking about, the data value we're talking about is 30. I have to find the z-score that goes with that, plug it into my formula, and I find that that z-score is 0.82. So then I go to my table and I look up the probability that I'm to the left of that z-score. It's 0.7939. So 0.82, that I'm to the left of that is 0.7938, but I want to the right. I want more than. So I'm going to do 1 minus that. About a 20% chance that you're more than. Let's do part B as well. B asks, what is the probability that I have less than an 18-minute commute? So the probability that x is less than 18. So my data value is 18. I use my z-score formula to turn that into a z-score. So 18 minus 25 divided by 6.1. And I get negative 1.15. So I look that up on my chart, find the probability that I'm to the left of that. It's 0.1251. So here's negative 1.15. The probability that I'm to the left of that is what I have here. About 12, a little more than 12%. Ooh, I've been waiting for these kind. These are the ones where you have to go backwards. Notice in the previous 3 problems, you were given a cutoff score and asked to find the percentage chance that you got that score. Well, this one gives you a percent, and then they want to know what score lines up with that bottom 5%. So this is reading scores that they gave a test, the whole school district, and they want to know what score is the lowest 5% of the kids. So they want that lowest 5%. I don't know exactly where that is. I'll draw it in about here. But I want to know, where is this going to be 5%? Well, first off, 5%, that's 0.05. So that would be 0.0500. Our charts show that. They show to the left of the z-score. So what we're looking at is we want to know what z-score lines up right here to make this area 0.0500. So look, now, this is going to be our probability. So look for 0.0500 in the middle of the chart. Then go to the outside to see what z-score gives you that. When you look, you might find that there's not one that gives you exactly 0.0500, so you might have to look for the closest one. I found that the z-score that gives me this is about negative 1.64. Actually, it's between negative 1.64 and 1.65. I'll just go with 1.64. So that's the z. Oh, so actually my z-score is about in here. This z-score right here, negative 1.64, gives me that area. Now that I know the z-score, now all I have to do is change that back into the data value. We're going to use a different formula to do this. Instead of the normal formula that we would use, this one, this takes a data value that you know and turns it into the z-score. We want to know the data value. So we're going to use this formula. It takes the z-score and turns it into a data value. So that's what we'll do. Our z-score that we have is negative 1.64. We'll times that by the standard deviation and add the mean. And we get about 93. So a score of 90, there's your average score on the test. A score of 93, that's going to be your bottom 5%. High school competency test, average score 400. Data is normally distributed with a standard deviation of 100. We want to find the cutoff score for the top 3%. This is another one where we're going backwards. Let me tell you what I mean by going backwards. If you remember in numbers 6, 8, and 10, we started with a data value. Then we changed it into a z-score, and we used that z-score to find the probability, either that it was to the right, to the left, in between. Well, on these backwards ones, on number 22 and 26, you start with the probability. Then you use that probability to find a z-score, and then you turn that z-score into a data value. So we're following this same path, just backwards. So we want the cutoff score for the top 3%. Where is that going to be? Well, the top 3%, I don't know, I'm guessing it's right in here. So I want to find this z-score to match up with this top 3%, 0.0300. Well, if that top percent is 0.300, remember that our table shows us to the left. So we'll have to look to the left, and to the left, then this would be 97%, 0.9700. Okay, so go to your table, look on the inside for 9700, and get as close as you can to 9700, and then look on the outside for that z-score. We are looking for the z-score that gives us that. And my table tells me about 1.88. My pick's a little off again. 1.88, about there. That'll give us the top 3%, a z-score of 1.88. So now that we know that our z-score is 1.88, now we have to use the right formula to turn our z-score into a data value. The formula to turn a z-score into a data value is you take the z-score, times it by the standard deviation, plus your mean. So that data value is 588. That's the cutoff score to be in the top 3%. The bottom 1.5% go to summer school. What score do you have to get so that you're not in that bottom 1.5%? Here's our bell curve. Bottom 1.5%. Somewhere down in here, probably. This will be 1.5%. Probably the trickiest part of this problem is making that 1.5% into a decimal. You have to move your decimal place 2 places. So that'll be 0.0150. So you want, that's your probability that you're to the left. So that's the number that you want to look for on the inside of your table, where the probabilities are. Look for 0.0150. You're looking to find the z-score that gives you that probability. So when you find 0.0150, look for the z-score that goes with it. I get about negative 2.17. So if my z-score is negative 2.17, I now need to change that into my data value. I'll use this formula. A score lower than 183 will send you to summer school. The average yearly Medicare hospital insurance benefit per person was $4,064 in a recent year. The benefits are normally distributed with a standard deviation of 460. I've crossed out some words to make this look like a problem that we've done in previous sections. Actually, earlier in this homework. Earlier in this homework, like problems 6, 8, and 10, it would have said, find the probability that the benefit for a random patient is less than 3,800. Notice that you're looking at finding just one patient. So what's different in these problems? In these problems, you're looking for the mean of a sample of patients. So the mean value in a sample of patients. So what's different? Well, when you find the z-score, instead of using the old way, the old formula, take your data value minus the mean over the standard deviation. That was for problems 6, 8, and 10. For this problem, for number 18, you're going to use the central limit theorem. You're going to use this formula. The mean of a sample minus the population mean over the standard deviation divided by the square root of n, where n is that number of patients. That's basically the only difference in this problem versus the problems that you worked in 6, 8, and 10. So our population mean, 4,064. Our standard deviation, 460. And our n, that's how many patients are in the sample that we're taking, 20. So I want to know that the mean x is less than 3,800. Okay, so that means I'm going to find the probability that the sample mean, x bar, is less than 3,800. So I'll start with that x bar of 3,800. I want to change that into a z-score. Again, the way that I know to use this formula right here is because I'm looking at a sample of patients and I'm looking at the mean benefit of the sample of patients. So find the z-score that goes with that mean of 3,800. So my 3,800 minus the population mean divided by the standard deviation divided by the square root of 20. I plug that into my calculator. I like to do the top first and get a number on the top. And then I do the bottom, 460 divided by the square root of 20, and I get a number there. Then I divide those two numbers to give me that z-score. That is a z-score. So then I make my picture. I want to know what's the probability that I am less than 3,800, less than that z-score. So less than that z-score. So I go to my table and I look up that z-score and look up the probability that I'm to the left of it. And it is 0.0051. And that's my probability, less than 1%. Very similar problem. Find the probability that the mean benefit for a sample of patients. So I'm looking for the mean benefit for a random sample. That's how I'm going to know to use this formula to find my z-score. Everything else is the same. So I'm still going to use these same numbers for the population mean, the population standard deviation, and the n. So I'm looking to find the probability that the mean of my sample is greater than 4,100. I need to change that mean into a z-score. I'm going to use this same formula. My x bar, my mean, 4,100, minus the population mean, divided by the standard deviation, divided by the square root of n. I type the top into my calculator, then I type the bottom into my calculator, then I divide them, and I get a z-score of 0.35. So I want this area more than a z-score of 0.35. So I go to my table and I look up the probability that I'm to the left of that z-score is 0.6368. So this area is 0.6368, but I want the other half, so I do 1 minus 0.6368. I get 0.3632.